€10 billion per year. That's the cost that comes together due to natural disasters within the European Union every year. And 9 of 10 European Union citizens expect that other countries come to help when there's a major natural disaster, such as an earthquake, a volcano catastrophe, flooding, things like that. And these two things form the groundwork for the European Union Civil Protection Forum, which is taking place here in Brussels, the capital of Europe.
Ladies and gentlemen, despite the progress made, there is always room for improvement. We can do more. We can do better. Our ultimate goal must be to cultivate a risk management culture throughout our societies. We need to work more closely with all interested countries to develop commonly shared principles, objectives, and working methods.
Thank you very much, Commissioner.
There is a lot of robotic technology which exists in labs, in research labs all over the world. But if you look at the practice on the field, you see that these robotic tools aren't so much used as they could be in practical operations. So they wanted to fund a project which could bring these robots to the field. So that's how ICARUS was born, a project funded by the European Commission. We have 24 partners out of 10 different countries, and we have the support from 2 major end users. It's BFAST for all the operations on land scenarios, and the Portuguese Navy for all the operations on sea scenarios. Now, if you want your robots to work together, and if you want these robots to work together with the search and rescue workers, well, they have to communicate in the first place.
Yes. Nice.
With this one single station, we are in charge of controlling the whole operation in search and rescue. So that involves controlling robots, giving them high-level commands in order to achieve or to take some pictures, camera imagery, thermal imagery of a particular area. It could be ground robot, it could be a marine robot, it could be an aerial robot. And all these systems are allowed to work together. Multi-domain is the main focus of our base station. So the data from each robot is visualized here. So search and rescue operators can analyze the data and identify potential areas of interest and also victims, which are the main focus of this project, is to identify them as well as rescue them.
Now, obviously, this is not a window, and it's not a building either. It simulates a collapsed building. Imagine you had an earthquake or a major tsunami, which has just really dismantled infrastructure. Now, what are you going to do? You have to rescue people who are just stranded in this collapsed building. And for that one, use best robots, because sometimes it's simply too difficult to send human rescue teams over there. But the robots have to be able to crawl into the cellars, to take away stones and stuff that is blocking the way. And this is exactly what this Eurothlone competition is doing. It just takes lots of robots which are specialized on different things to rescue people and just checks out how they work best. And ICARUS is participating to this Eurothlone competition because the objective of the project is to develop these robots.
So there are several aims and objectives, but the big one is really trying to accelerate the transfer of intelligent robotics to tough real-world applications. And of course, we want to work with research projects like ICARUS, but to take ICARUS as a specific example, the best thing that you could do is to bring teams to Eurathlon events.
I am very satisfied. The organizers prepared very nice demo site. The task is very sophisticated and it is very close to the reality. I discovered some important issues concerned to my robotic platform. First of all, as usual, communication is an issue. So we could not penetrate all underground structure. And concerning this scenario today, we can observe the issue is that our sensors is not enough to achieve the goal with perfect scores because the smoke is too intense.
We just finished our run in the underground scenario. Essentially, we had to go into a tunnel over there, which was filled with very, very thick smoke. So it was very challenging. A lot of the standard approaches in mobile robotics would have failed. The use of laser scanners, ultrasound sensors, different kinds of depth imaging wouldn't really work in this scenario. As we saw earlier, a number of teams relying on these techniques with autonomous robots could not go very far because of the thick smoke and the nature of the challenge. 4 or 5 years ago, the impression was that firefighters are very hesitant to rely on any sort of autonomy to do tasks. They don't trust it fully and they think it might make things worse for them when they actually have to go in. Definitely, I think Eurathlon and competitions like this will help not only firefighters but also the general public to see the importance of using mobile robots and tools such as this.
Will then look into this area and completely automatically it will detect these victims. Just to let you know, it is not the RID.
This drone will be with the team, with the search and rescue team. They will just come with the van or whatever. They will just very quickly mount it and then start flying. So when they reach a disastrous area, they will just see rubble, for example. Quickly flying this over the rubble will start giving them immediately information, live stream of the video, but also this map generation, very quickly map generation, detection of the victims, 3D reconstruction, etc. So for the operators, the ground operators, it will be very easy to immediately have a very, very good image of what is happening. They can have very quickly the first overview. And then when they say, okay, this area I want to explore in more detail, then also these kind of drones can fly there and more slowly and maybe on lower altitudes be scanning for victims, be searching for victims, etc. This is just a fake kit, but it is supposed to be a safety kit, so it can contain like water or any medicaments. Exactly. It can weigh up to 1-2 kilograms. It depends then on the autonomy and everything. But so when you see the victim from the thermal camera, the operator can say, okay, drop the safety kit or drop the flotation device to help the victim. We did give it to a complete stranger. He is from a search and rescue team, so he knows a lot on operations of search and rescue, but he had never flown a UAV. Immediately he took it, going up, down, front, and he was, after 30-40 seconds, he detected a victim. So it was amazing.
This was a mission together, with ICARUS and the Tiramisu project, so both projects participated, done with Belgium First Aid and Support team, so the BFAST. We were there on several locations, so I think around 15 locations. I was, of course, focusing to give the support first for the BFAST. We were the first team deployed, and then we could find it, and then not only that, because it's not only about aerial reconnaissance which we are doing, it's also about mapping. So we do a lot of mapping activities with such type of vehicles, also building digital orthophotos, terrain models, surface models, and so on. And all this data serves as a first, let's say, input. If you provide also data, for example, in this case, from mine action, so we could fuse these two sources, and then we could predict and obtain new risk maps. So this was very important. For sure, I see the potential, the huge potential of these tools for search and rescue teams, but also for mine action teams. Integrating these tools in their standard operational procedure. So people from the field, the miners, will use this. And on the other hand, the search and rescue community, the BFAST leader, the feedback he gave us, and the communication we started after we returned in Belgium, I see big potential, and they will also go for this type of tools in their operational procedures.
Actually, we are.
It's the year 2015. More than 100 years have passed since the Titanic sank, and still we lose on average 2 major ships every week, according to the insurer Allianz. What can we do to improve search and rescue operations? Can we use robotic means? Can we use aerobots, unmanned surface vehicles to improve the situation? These are exactly the questions we're going to ask and to answer here at the last field demonstration, the maritime demonstration of the ICARUS project, a European Union project. And we answer these questions here at the Alfete base, the naval base, the base of the Portuguese Navy.
Drones are in the news everywhere. It's everybody's opinion that drones can be very effective, very cost effective for each mission. And I think we have to be ready for that technology in the near future.
Para continuarem a ser intermediárias num processo que tem a ver com o leasing dos C295 e dos EH101 e, portanto, irão desaparecer, porque não. Thank you so much, and I wish all of you the best for the exercise, for the projects, and for your enterprises.
It's
a fact that the number of large catastrophes is increasing and the cost of answering, rescuing those operations is also increasing very much. Today, the scenario that you'll see is a simulation of a large accident with passenger ships. What will happen is that one of the Navy passenger boats, the Zezra, which is already standing at anchor, will have an explosion aboard, there will be a fire, and victims will fall in the water. After that, our assets will be deployed. First the aerial assets, then the surface ones will show their capabilities.
The first thing, of course, is to know where the victims are. There will be a plane with visible camera and infrared cameras. The plane will make a recognition, a search, and identify the people. At an RC2, which is the central station, they will recognize the victims and they will make a georeferentiation of the victims.
So you see it here, yeah, okay.
After this, we can also deploy a copter, an octocopter, that can go to each of these clusters of victims that is already identified in the sea, and make a better evaluation of the situation of these persons that are on the sea.
What is the height of the crane?
There will be two ships. One is called ROAS, developed by INESC, and another Ranger, developed by CMRE. So these two means will go to these victims and try to rescue them. The ROAS from INESC will go there, deploy a small ship called the UCAP, which then will go directly to the place where the victims are and deploys a raft, and the raft opens automatically and the victims go there.
The most important thing I noticed here, at being 20-something entities working together, it was perfect because they would work all together, and the cooperation was very outstanding, and I think they complement each other with their knowledge, and that's the big thing I would like to stress in this project.
April 2015 saw one of the strongest earthquakes in history happening in Nepal. And this is a structure here which simulates such a simulated crashed building, a pancake house, just as we found in Nepal. Well, we're not in Nepal over here, we're in Marche-en-Famenne. Marche-en-Famenne is a village in the Belgian Ardennes of the Belgian army, and here we can simulate such an earthquake. This is the ICARUS team, a Horizon 2020 project, together with the Belgian army and together with the Belgian search and rescue team, the Be Fast team. Because if something like that happens, you gotta be accurate, you gotta be precise, you gotta be fast, because you have only 72 hours to rescue people. After that, the survival chances decrease exponentially.
located the victim.
What would you really put as top priority that you would buy on the shopping list?
Certainly the quadrotor, so this small helicopter type of unmanned aerial vehicle, because I really believe when you go on site and you have a quite big sector to cover, it makes sense to have good pictures that will help the team leader to make his assessment and his approach about okay, which is the angle we will take to attack this building in order to look and to search for victims. This is certainly one. Then ground robots, I really believe in them, depending on, of course, their size. That's also very important.
We see robots as an extra tool in the toolkit of the search and rescue people. So it's not like we want to replace them, we don't want to replace the dogs either. Here the use of the tool is, of these robots, is that they can go into semi-demolished buildings which are dangerous because there is still danger for collapse.
It can really sense its position and the environment around and can then decide if a window opening is large enough to go through. And it helps the user actually to tell him, well, you can try, but no, there's no way.
There have been quite a lot of tools which are not only usable in the case of earthquake, especially when you look at the case of the mapping and situation awareness tools. And it's both the ground vehicles and the air vehicles which are really bringing a lot of new possibilities into our workflow.
On the door, and this is to give the operator a sense of distance.
The exoskeleton is a master device, so it allows to control slave device like this robotic arm. So the way it is working is on this system, on each joint, on each motion, we have sensors that measure the position of my arm, and this position is sent to control the position of the robot. If I enable this control by pressing the button, I can now show you that if I go up, the robot is going up, down, and I can also control different joints of the wrist, for instance, like this one, to enable manipulation of objects. The good thing about this control is that the robot is following what I'm doing with my arm. So if I want to open a door, it is very easy for me to make the same motion with the slave robot.
Oh, that was a really good project. They were end-user driven, they really listened to the needs and the requirements, and they really took it serious.